So before we get underway, I wanted to mention a couple of things. First off, I had intended, which I have now decided I'm not going to do, but I had intended to print out reports from Blackboard on people's progress. I did this for my A&P1 classes, and I wanted to get it done for you too. But I can print out a report that looks something like this with all the assignments and the scores that you have. And it shows what assignments you haven't completed, and then at the end, the score that you have from that work that you've done. This is essentially exactly what you see if you go into My Grades. There are two exceptions, or two differences between them. One, this is in the gradebook order. I think when you go into My Grades, what you see of assignments are in some sort of weird order. I don't quite understand that. Also, this will not show you what the exemptions for makeup assignments. So for instance, this one right here that doesn't have a score next to it is a makeup assignment, but it doesn't say that this person's exempt from that because they were present that day or something like that. So as far as that's concerned, the My Grades option is a better one to see that stuff. Now, my intention was to print that out today, but I ended up having an appointment this morning, and I got onto campus at about 10:15. And I wouldn't have been able to get caught up on the grading and print out all those reports for everybody before class, so I didn't. I would suggest to you that you look at the My Grades section of Blackboard and pay attention to what you need yet to do. Now, I'm printing it out for my A&P1 students because I think they need that kind of kick in the pants, so to speak, to show what they have left to do. But being an A&P2, you're a little bit more advanced student. You should be a little bit more on top of the things that you need to do. So I'm not going to print this out. I won't have time to do it before Thursday anyways, because I have another appointment Thursday morning that's going to take up all my time. So I'll just leave it to you. You need to pay attention to what you have left to do. I want to remind you that the last day to get anything done is the day of the final exam period, when we'll be taking the check and practical. I have open here, the Monday lab group section. So if you're in the Wednesday lab group, what I'm about to show you doesn't apply. Your lab schedule doesn't apply, but not that you can read anything on the board anyways, but down at the bottom of the schedule for both sections, it says May 12th, Lab Practical 2. That's the final exam period for this class. If you go to the stick.edu website and pull down the menu that starts with library at the top, it has the final exam schedule. And if you look in there, it says that classes starting between 11 and 12:29, Tuesdays and Thursdays, have their their final exam period at 11 o'clock on the 12th, which is Tuesday, right? Yep. Yeah. We'll be doing that in the lab room. It's based on when we have the lecture section, but we'll be in the lab room for that because it'll be the practical, and I need to set it up from there. All of your work needs to be done by then, okay? That is the absolute final due date for everything. When you come in to take the practical, I'll turn off access to Blackboard for the different sections, meaning the Monday and Wednesday lab sections. So you won't be able to do any work in Blackboard after that time. You have to have everything done by then. If I handed out the report to you, you could use that as a checklist of all the things you need to complete. But go ahead and use the My Grade section in Blackboard for the same purpose. Make sure you have everything completed. If it doesn't have a score, if there's a hyphen dash where the score would be, that means that you haven't gone into the assignment yet, you haven't completed it, you haven't submitted it. If there's a score there, then obviously you've completed it, it's been graded, everything's fine. If it says in progress, that means that you've opened something up, but you haven't completed it, and you need to go in and complete that. If it says needs grading, that means that you've completed it, you've submitted it, and it's waiting for me to grade. If there's a gray circle next to one of the makeup assignments, that means that you're exempt from that and you don't have to complete it. I believe on the makeup assignments that you're exempt from, it'll also have, well, for assignments that you have to complete that you haven't even opened, there'll be a dash and then the total number of points. I think that's what it looks like in grades. If you're exempted from something, it won't have the total number of points, and it should have a gray circle. I'm trying to make a gray stippling pattern, but you know what I mean. There should be a little circle next to it. If you hold the mouse over the circle, you'll have a little text box pop up that says exempt. Okay. If you don't know what the gray circle means, if I haven't said it enough times, hold the mouse over it and it'll say that gray circle means that you're exempt from something. Being exempt from the assignment means that it's not factored into your grade. The total number of points is based on the number of assignments that are out there. So, because I know the numbers offhand, thinking just about one chapter, the part 1 is 10 points, part 2 is 10 points, part 3 is 20 points, part 4 is 18 points for a total of 58. And then whatever your score is, if you get 9, 8, 17, 12, those are added up to be 20, 30, 48. I think so.
Yeah.
Okay. So your score is just 48 divided by 58, whatever that comes out to be. And I'm not going to try to do that math in my head. If you have an exemption, then you won't have an exemption on any of the part 1, 2, 3, 4 things, but I know those grades offhand. If you had an exemption for this, if there was a gray circle in that, then that's just not counted here. Okay. So there'd be no grade there, which would get us to what? So then your grade is just whatever 39 out of 48 equals. Okay. That's what the exemption means. That does not count for you. You can complete those makeup assignments if you want to for the extra practice or whatever, but if you're exempted from it, it just doesn't count. There are people that do those, again, for the extra practice. I've attempted adding those in, and it always brings the score down. Not a whole lot, a point maybe overall, which doesn't have any real effect on the letter grade, but there is a benefit to being exempted from things. So I'm leaving those exempt. I will not allow anybody to use any of that stuff as extra credit. That's not extra credit. Even if you did it, if you were here that day, it's exempt. If I count it in, it makes the total number of points that your grade is based on bigger, which means that it's likely to bring your grade down a little bit. So in my grades, pay attention to those things. That's what the gray circle means if you've forgotten. Everything must be done by the time you come in for the final, which is the 12th at 11 a.m. Now, actually, there's 26 people in this class. I don't have the grades handy to really look at. There are probably a couple of people in here that, maybe not. I was going to say there might be a couple of people in here that not showing up for the final actually wouldn't hurt their grade any because it's already pretty bad. But I don't want to say that to anybody. There's 26 people who need to take it. There's 24 chairs in that room. So not everybody can come in at 11 o'clock. What I've done to deal with that is I've just staggered the testing time. So the Monday lab group people will come in at 11. The Wednesday lab group people come in at 12. Okay? Everybody gets an hour and 50 minutes to complete the test if you need it. The test can probably be completed in about an hour, but for those people that need to hang on, there might be 2 or 3 people from the Monday lab group that are still there at 12. They can just keep working through the rest of the period. People that come in at 12, the Wednesday lab group people, if you're not done by the end of the lab, end of the final exam period, I'll let you stay on for another, well, technically hour, so that everybody gets an hour and 50 minutes to complete things. But most people are done. I can't think actually of any semester that I've ever had anybody staying past the end of the final exam period. So everybody should be done fine. It's just to make sure there's enough room for everybody to have a seat. We'll just stagger it. Monday lab people, you'll have to come in at 11. Wednesday lab people come in at 12. I don't want people deciding to just come whenever they want to, okay? Come in when I just said based on your lab group time. When Monday at 11, Monday lab group come in on the 12th at 11 o'clock. Wednesday lab group come in on the 12th at 12 o'clock. Okay. Don't show up whenever you feel like it, because if everybody did that, then we wouldn't have enough room for everybody sitting in the room. So please honor what I'm saying here. If there's some horrible problem that you can't be there at that time, let me know and I'll try to work it out. You are supposed to actually be in class at 11 o'clock on Tuesdays, so I know that's not going to be a problem for anybody to show up during that time period. But if there's some conflict, if you're in the Wednesday lab group and you normally go to work at, when do we finish up here? 12:15? Like you normally go to work at 12:30 or something like that. And you need to start earlier, we can work that out. But I don't want people just coming in whenever they feel like it. If we haven't talked previously, then the Monday lab group people have to come in at 11. And if you come in late, then you won't get you'll only get up to an hour and 50 minutes after 11 o'clock. If you're in the Wednesday lab group and you come in early, I'll ask you to wait until 12 o'clock. Even though there are seats there, I want people to honor this staggered arrival that I'm talking about. So Wednesday lab people come in at 12. I will shut down access to Blackboard based on those times. So if you're in the Wednesday lab group and you want to spend that hour before the practical getting a few things done on Blackboard, you'll have that time. I won't shut down the access for the Wednesday lab group until you're actually in the room. Okay. It might say 11 o'clock on the thing here, but in fact, I'll do it when you're physically in the room. So so if you need that 11 o'clock to 12 o'clock time to get a couple of things done, you'll have it. Okay. Is everybody clear on when the final exam period is? Okay. And when you're supposed to be coming to do that? All right. According to the schedule, which again, you can't really read what it says on the screen right now, but today, the 28th, it says renal function. We, of course, finished with the renal function last week. So we're going to start the reproductive system. I went ahead and changed the current week and next week links in Blackboard to reflect that, although I didn't change any due dates. So technically, the urinary system chapter assignments aren't due until Wednesday night. So you'll be able to keep working on those. But Um, we just going to have to start up with that. Now, I usually am running out of time at the end of the semester, so this is a very unusual semester that I'm actually a lecture ahead. So there's a very good chance that we won't actually need to come in on Tuesday the 5th. Okay. Well, I can't say that for certain until after, till the end of class on Thursday, but I might at the end of class on Thursday say, well, we're done with the reproductive system, so that's it. So if that happens, then you'll know at the end of Thursday that there won't be lecture on the 5th. There wouldn't be lecture on the 7th because even though that's a Thursday, it follows a Wednesday schedule to make up for snow day rescheduling issues. So the Tuesday would be our last lecture anyways, but it's entirely possible that we won't need it, even though I'm burning up a lot of time talking here at the beginning. Okay. I'm almost positive I'll be done with the reproductive system on Thursday. But I don't want to say that definitively now. Wait until at the end of on Thursday, and I'll let you know if we have class on Tuesday. I think that's what I want to talk about, the making sure that you're aware of what you need to get done and when it needs to be done by, staggered start times for the final period, and we may or may not have class on Tuesday, which I'll say on Thursday, this Thursday, definitively what that is. Any other outstanding questions before we get underway here? Oh, I do have a question I want to pose, which you don't necessarily have to answer right now, but to some degree it was kind of sparked by, well, at least half of you people. This morning I was trying to get caught up on grading, and the Monday lab group section, not that there's something weird about you, but oh my God, I had 115 assignments that I had to check off, okay? The Wednesday lab group, I had like 12, okay? So there's something very dramatically different between the people that are in the Wednesday lab versus the Monday lab. And I don't understand why that is, but part of what I think pushed that number up is people that are sort of taking the sort of brute force approach to trying to solve part 3 assignments. And so there's, 30 or 40 assignments from somebody that's been handed in, and one blank on in all of the blanks in a part 3 assignment is the only one that's getting anything put in there, and everything else just is left blank. That doesn't satisfy the spirit of why I set up the assignments that way. Now, I'm not going to change anything for you because it's, of course, too late, and then you'll, of course, be done with me after the semester. So what I'm about to suggest has no personal bearing on you. It's not going to affect you whatsoever, but I am planning on making a change, and I would like some honest reaction to this. Your reaction will not color my impression of you in any sort of way, but what I was thinking of doing, and I think this is a good idea from a teaching point of view, but students will hate it, I'm sure. Instead of the final, the final attempt being the grade that goes in the grade book, I want to change it to being the average of all the attempts. Okay. It'll be for 1, 2, and 3.
No.
Okay, this won't affect you, but here's the idea. If you're looking at a part 3 thing and you're like, well, hell, I'm just going to start plugging in answers to this blank until I can find the correct answer, that's going to actually be quite detrimental to your grade, okay? If you wanted to do that, then you would just have to plug in all of the answers, and hopefully, if they're say 10 blanks across the 5 questions there, and 9 of them, and you're just trying to figure out the 10th one, then as you're plugging those all in, you can do 40 attempts, and you're going to get, like 18 points on each attempt until you get that last blank correct. That'll make for a very nice average, and you'll be way up there average-wise. But it will keep people from doing this brute force solving method.
Well, since we got to do it, I like it. But if you were going to do it on like a future, I think it would definitely make them look more into the answer instead of just.
Yeah, the point here is that, yeah, students aren't going to just sit there and take this brute force approach, but rather actually spend some time thinking about what the question's asking and figuring out what the answer is supposed to be. Okay. So,
about changing the question the way you change on the others.
Say that again?
You change the questions. You ask something similar to what you had asked before, but you change the question
On
the like part 3.
So in part 3, the questions don't change. You always get the same.
So when somebody does it like so many times, you keep changing the question.
I don't change the questions.
Yeah, that's what I'm saying. Instead of finding the average, just change the question. Like the way we do it in part 1 and 2.
So like they have to get
Right, but then people will still take the brute force thing. It'll just be that there'll be 100 versions.
That's what we do with part 1 and 2, honestly, already.
Right, and so with part 1 and 2,
Part 1 and 2.
yeah.
Okay, everyone basically like.
With a multiple choice question, you really should be able to pull that up, look at the answer choices in front of you, and figure out what's correct and get it in one shot. Okay, but sitting there and doing it each question 4 times and just hitting A the first time, B the second time, C the second, and figuring out which one's right that way, that's not learning. Okay, so I think I want to switch to this average model because then
We
people.
do it like the way we do it the exam, the last exam, the final exam. You're not gonna get the same questions.
Yeah, but you know how many questions I'd have to put in for that to work out for everyone? Sorry?
You have so many questions.
I'd need so many more for that to work for every different thing. Some of those part 1 and 2s only have 20 questions. So over 5 or 6 attempts, you're going to cover all the questions. And if you do it 20 times, you're going to be able to get all the questions and just solve them by plugging the answer choices in. So. Okay, if you have anything you'd like to share more in depth describing your feelings about if I did that to you as a student, although I will not.
Well, we're not
No, again,
it's for future students.
Yeah, so again, this is not going to affect you at all, but you as a student, knowing how this class works, if you have any feedback to give me on this, I'd appreciate it. You're not going to actually change my mind. I'm going to do this. Because I really need to find a way to get people away from this brute force solving method because it's not helping people learn things. I was listening to people talk about answers that they were putting in, and people are overthinking things too much, and they really need to step back and consider what's going on with the question and ask for assistance. Okay. So few students actually ask for assistance on things. It's incredible. Now, if everybody asks for assistance on every single thing, there's no way of getting the work done, but there needs to be a happy medium in there. Some people need to spend a little bit more time going to the source and getting better information. Okay. So just if anybody has any feedback that you'd like to give me other than stay this way, we like it, I'd appreciate any text or emails that you have to send my way. But it's not going to affect you. It's not going to change how you do anything in this class. And of course, once you complete this class, you're probably not going to see me again. So you're not going to have to deal with this anyway with me. But I would kind of like to get a little feedback to help me anticipate the kind of reaction I'm going to get from students in the future.
Well, don't tell them that our option never existed and then they won't even care.
Well, I'm going to be doing it for people that are in A&P1 now who are going to take A&P2 from me. So, yeah, they probably won't, but hey, it's college, deal with it. So, yeah, but I would like if anybody has anything to share to get some feedback there.
3 attempts and that's not in 3, just 3.
That's another way. I probably wouldn't do 3 because you have to get a certain score to go on, maybe 5 or something like that.
That'd be good.
And then you're
Well, no, if I did 5, then you could go through and, no, I'll have to think about it.
Four, because that would give them enough time for each question. Wait, how many questions?
Yeah, but see if it keeps recycling, I mean, if it changes the questions, I'll have to think that out a little bit. We'll see. Okay, let's get on to actual stuff. Before class, as I was setting things up, I put the various figures that I want to deal with in tabs up here so I can just go to them real quick. As I was doing that, all of the material that I want to talk about in lecture for the reproductive system is presently in all those tabs up there. So that kind of reinforced a little bit the idea that, actually not, there's a couple more things I need to cover, but it is going to be kind of, I'm almost positive I'm going to be done by Thursday afternoon. I mean, by Thursday's lecture. But again, don't start making plans for next Tuesday until I say definitively that I won't have class then. So we're in the last unit of the book. There are 2 chapters here. There's the reproductive system chapter and development and inheritance. We are dealing with the reproductive system chapter. The introduction part, of course, is just the opening blurb. There's nothing to it much. Then the chapter is broken down into the male anatomy and physiology, the female anatomy and physiology, and then development of the both systems. The way that I've always set up this part of the course, especially because I'm usually running out of time at the end of the semester, is I use lab to deal with the male side of the system and lecture to deal with the female side of the system. And I'm going to keep with that because really the assignments that you have are all based on that approach. The case study that has to do with the second practical that deals with the reproductive system is obviously the male reproductive system. And then I focus on the female reproductive system, especially with the part 3 and part 4 assignments for this chapter. So this is essentially what I want to cover today. I do want to, at the end, and this is the couple of things that I realized aren't actually in tabs yet. I want to go to the physiology of the male system at the end to kind of tie together how the 2 systems are regulated the same way, using the same hormones. But again, that's probably something for Thursday. I will not be dealing with the development aspect of this chapter. Just across the board, I don't tend to deal with development outside of development of the nervous system in A&P 1, but generally I stay away from developmental issues because that's really a course unto itself, and I don't want to expand this course that much more. So for what we're doing in lecture, it's really just this section that's on the female reproductive system. You don't have chapter assignments from the development or inheritance stuff, but there are some things from that I cover in lab. Half of you from yesterday know that. The other half, I'll cover that in lab.
Next month.
Oh, that's a good point.
Is it Monday tomorrow? Or is that next week?
Tomorrow we have the urinary lab.
Yeah. Which, thanks for bringing that up. Those of you in the Wednesday lab group for tomorrow, if you tend to go to the restroom before lab, please come to lab first. Need to collect a sample there. So anyways, yeah. So the Wednesday lab group, it'll actually be the 6th that we end up doing that. That'll be our last lab period. The 7th, which is a Wednesday schedule as far as the school is concerned, we won't be having lab. I've set that aside as one of the possible optional section dates. But for those people that have responded, either the day you said you can come, that's the day we're doing it, or I contacted the person that had given me the other date. So the optional section thing's all set. And the Wednesday lab group, you just have lab tomorrow and next Wednesday. You don't have it on Thursday the 7th. Okay, so on with what we're doing. The female reproductive system, the organs that are involved, the ovary is the reproductive gland, which is where the egg cells are generated. We're going to talk about that process a bit more today. The sagittal view that we have here doesn't show the connection between the ovary and the uterus. We have to go to this anterior view here. So the ovaries are off to the side. They're this kind of, I don't know, teal color or whatever. The tube that comes from the ovary and extends down to the uterus here has several different names. Uterine tube is a straight anatomical name for it. Oviduct is kind of a Latin name for it. Ovi, meaning egg, so it's the duct that eggs move along. It's also referred to as the fallopian tube, which is, I guess, kind of an old-fashioned name for it based on somebody's, whoever first described it, that person's name. But we'll tend to use a uterine tube. Again, a nice straightforward anatomical name for it. That starts with these finger-like extensions called fimbriae. The tube is not actually connected to the ovary, so when the egg cells leave the ovary, they have to be kind of coaxed to move into the uterine tube. And so these fimbriae will kind of move a little bit and push the egg cell into the tube. The tube gets progressively thinner and thinner as it moves towards the uterus, and sort of its thinnest point is right in here where it connects to the next part, which is the uterus, which I can see here in the sagittal view. This is a very muscular organ. The muscles are all smooth muscle, but they can generate quite a bit of force, partly because it's such an extensive muscle layer. That opens up at the cervix, which we see here in the sagittal view, or in the anterior view, we can see the cervix opening up here, which then leads into the vagina, which is the muscular wall that serves as the birth canal, as well as serving as the route that the male reproductive tract gets sperm into the system. I like to concentrate on the internal organs because I really want to concentrate on the hormonal regulation and physiology of the system. The book does cover a bit more of the external anatomy, which you're welcome to look into, but the questions in the assignments really are about the internal anatomy, which we'll focus on here. Oh, that's right. In talking about the reproductive tracts for both male and female systems, I want to kind of concentrate on where the reproductive cells are made. And sort of part of the basis of that is some of what I talk about in labs. So the Wednesday lab group, I won't really get to that completely until next Wednesday, but this kind of gets at some of what's happening in the female reproductive system. And there's a very similar picture for the male reproductive system that I showed in lab yesterday, or I will next Wednesday. And I do want to take a second to cover something that I didn't really cover in lab very well yesterday. So what's happening here is a cell called the oogonium, which is the stem cell. The the double O part of this word, is the root from the Greek that means egg. And then gonium is just the rest of the word that's describing this as a stem cell. There's an analogous cell in the male system called the spermatogonium, or this, is that right? Spermatogonium? Something like that. Seems like I'm saying too many syllables in that word. But Anyways, that cell undergoes mitotic division, generating two clones of the original cell. I can kind of see why this happened. They put the word primary oocyte on the side here. This particular circuit right here, this particular circle right here that has an arrow pointing back to the oogonium is not the primary oocyte. When this cell divides, one of the cells is then going to continue on through the rest of the process to make the egg cell. The other one remains as a stem cell that stays put. So this one that's going to continue through the rest of what's happening here is really the primary oocyte. The one that looks like it's labeled with that is really the persistent oogonium that'll be available to make other cells. These cells are labeled with 2N representing the number of chromosomes in those cells. And I want to talk a little bit more about that. I sort of mentioned it in lab yesterday, talking about the male system, but I want to define this a little bit more. First off, the Monday lab people can tell me, well, hold on a second, I got to ask that question. Mitosis is simple clonal division. So the Monday lab people can tell me what I mean by calling something a clone. How did I define that yesterday? No?
It's only like a split of cells at the end. It's only one line, so you only have one instead of 23.
No. Almost the exact opposite of what you're talking about, but it's not in that context that you're getting at with chromosomes. What does it mean for something to be a clone? But we can be more specific. Same in what regard? Yeah, it has the exact same DNA. Okay. So the oogonium, or spermatogonium, has a full set of chromosomes. And when it divides, the two resulting cells have the exact same full set of chromosomes. Okay. That's a little bit outdated term. Okay. So just the resulting cells, the offspring cells, whatever you want to call them. This occurs for pretty much all body cells. And I'm saying pretty much here, kind of hedging my bets, because there are some exceptions to some of these broad statements I want to make. So I'm just kind of allowing for that. But essentially, all body cells divide this way. How many chromosomes do we find in your average body cell? No? Come on, Monday people. How many chromosomes? 46, right. So Caitlin, the 26, actually, who said that yesterday? Yeah. That's a forgivable error because the number is actually 46, but half of that's 23. And both of those numbers are relevant. So Jessica said 26 yesterday for, I think, the same reason. But so 46 chromosomes, duplicated, and distributed. That's where I want. So I'm using the term offspring cell here as the question came up earlier, aren't they called daughter cells? The term daughter cell is actually falling out of use, partly, which is somewhat silly, I think, but partly because it sounds sexist. But also, I'm okay with using more general neutral terms just because I think it can lead to some confusion because the word daughter, especially if we're talking about reproduction, does get people thinking about, a baby girl or something like that, and that's not what we're talking about here. So the gender neutral language here is used kind of on purpose. So if you see daughter cell, that is a term that's kind of falling out of use. So in mitosis, this is sort of the straightforward type of division. We make clones of the cells. This is going to apply to pretty much all the cells in your body. And for humans, there are 46 chromosomes. Those are duplicated, and then one set is sent to each of the 2 resulting cells from that. 46 chromosomes represents 23 pairs. Okay. So really, humans have 23 different chromosomes. You get one from mom and one from dad. And so we have 46 chromosomes because there's 2 of each chromosome. Now, the 23rd pair is the sex chromosome, so it's a little bit different exactly what's happening there. But we still consider that a pair. Your average body cell having 46 chromosomes is called diploid cells, which is represented with the notation 2n. Okay? So 2 is referring to the fact that there are pairs of chromosomes, and then n is the ploidy number, or the number of unique chromosomes there are. So for humans, there are 23 different chromosomes, so 2 times 23 would give us 46. So back to this picture here, these cells up here have 2n written in where their nucleus would be to represent that they have a diploid number of chromosomes, or the full set of 46 chromosomes. The primary oocyte starts the process of meiosis, which is a different type of division, at this point. Now, in this picture, there's no obvious difference between this cell here and this cell here. They're both still denoted as diploid cells, and there's no division that's occurred here yet. But the reason that this picture is depicting it this way is meiosis begins with the primary oocyte that's made through mitotic division of the oogonium. It stops, or it arrests, that meiotic division in prophase 1, which is actually the very beginning of meiosis. But it sits there and does nothing. The line that we see here separates what's happening before the woman's born, or the newborn girl is born, and what happens after puberty. So this line here represents the dozen or so years between birth and the onset of puberty. And the cells are made originally in the fetal ovary, and they sit there having just started meiosis until they're ready to resume meiosis after puberty. Okay. What happens in the first division of meiosis is the diploid cell then becomes what's called a haploid cell, meaning that it just has 23 chromosomes. So let me go back here and continue defining this stuff. Meiosis is specialized division for gametes or sex cells. So meiosis is necessary for making the gametes, the sex cells, which is the egg or sperm cell, gamete just being the general name for those. And so up above, under mitosis, I have a point that says pretty much all body cells go through mitosis. I'm saying in the definition for meiosis that it applies to these gametes, the sex cells. So that's kind of the equivalent of the first point there. So here, 46 chromosomes are duplicated, and then distributed among 4 gametes. And we'll see a little bit more of how that process works in a second. These cells are called haploid, which is denoted with just the N. Okay, so the ploidy number, which is 23 for humans, you could also refer to as the haploid number. That's the number of unique chromosomes. So the gametes that we're going to see at the end here are haploid. They only have 23 chromosomes in them. And when 2 gametes come together, a sperm cell and an egg cell come together, that results in a fertilized egg cell, which then has 46 chromosomes again. And this is part of what's happening in the reproductive system, is to make new individuals that have the same chromosome structure as the parents. And I kind of said a lot of that stuff in lab yesterday. What I'm adding here really is the words diploid and haploid. Now, the DI prefix in diploid is talking about the fact that this is 2N. This is twice the number of chromosomes. Haploid, students will often look at that and think that it looks kind of like the word half. And in fact, N is half of 2N. That's not really what the word means, but if it helps you remember that haploid is half of diploid, that's fine. But that's kind of a circular definition. Diploid is twice of haploid, haploid is half of diploid. Really, haploid means the full number, not the full number, but the complete set of unique chromosomes, 1 of each chromosome. So that's what the prefix hap is really getting at. But if you see that word and half makes sense to you, and a lot of students sort of interpret that way, that's fine. Just understand that it doesn't actually mean half. It is, in fact, half the number of chromosomes that we see in most of the cells. But it's really the root number, the base number of how many chromosomes we have. And if we were going to consider these sorts of things across other species, the exact number that N represents changes from species to species. But still the idea that gametes have just that number of chromosomes in them, 1 of each chromosome, and then diploid cells have 2, representing a maternal and a paternal chromosome in each pair. That's kind of where the words come from. So in lab yesterday, as I was talking about meiosis and mitosis, I didn't introduce the words diploid and haploid, so I wanted to add that for yesterday, and then the Wednesday lab group, when we get to this stuff next week, we're that much further ahead of what I'm going to cover in lab there. So after puberty, the cell that is diploid here at the beginning completes meiosis, goes through the other phases after prophase 1, and divides into 2 cells. These are denoted as haploid because half of the chromosomes from this cell go in here and half of the chromosomes go here. Now, in the definitions I just wrote on the board, I said duplication and distribution of chromosomes. The chromosomes have been duplicated here, but half of the duplicated chromosomes go over here and half the duplicated chromosomes go over here. Okay. At this point, after the first meiotic division, we're now dealing with what's called the secondary oocyte, as opposed to the primary oocyte that is what started meiosis. The other cell that comes out in this division is represented by a smaller circle, and this is what's called the first polar body. Oogenesis, making egg cells, is not a symmetrical division. When the primary oocyte divides, half of the chromosomes go into one cell and half the chromosomes go in the other cell. But all of the cytoplasm goes into the secondary oocyte, and none of the cytoplasm goes into the polar body. So the polar body is just sort of this throwaway extra haploid nucleus, or at least that's the way that it's treated by most people. I just want to say that At present, at the textbook level and understanding of this, polar bodies are considered to be throwaway cellular material, cellular debris. It's entirely possible that we'll find out sometime in the future that polar bodies play an integral role in what's going on. But at present, there's not anything really known about the polar bodies doing anything. Just the way that scientific knowledge grows in your lifetime, you might learn that polar bodies do something else. I just want to kind of, again, hedge my bets that something might come of that. But at present, the polar bodies are kind of thought of as excess, and we just concentrate on the secondary oocyte. That then goes into meiosis 2, the second division. It doesn't complete that process until after the sperm's present, and one of those sperm cells penetrates to get into the egg cell and deliver the male nuclear material. At this point, we still have the nucleus in the egg cell represented by N for being haploid. The sperm cell is also haploid. We're not looking at sperm production in this picture, but the haploid nucleus of the sperm and the haploid nucleus of the egg cell, when they come together, they make a diploid cell, fertilized egg cell. Now, a couple of things that I kind of went over quickly, but I want to come back and point out. Meiosis begins in the fetal ovary. If you're a woman, you were born with all of the egg cells that you're going to have to use for your reproductive life. You don't make any new ones after you're born. You make, I think, and I can never remember the exact number, but I think it's like 400,000 egg cells. So you have plenty to last through a very significant reproductive part of your life. Sometimes in common thought, menopause is seen as when the ovaries run out of eggs. That's not at all true. Ovaries might very well have plenty of eggs left over. They just, hormonal changes have led to a different part of the reproductive cycle for the woman, and so they're gone. So they no longer progress through this. But all of the cells are present, and they've all at least entered into the very beginning of meiosis at that point. They sit and do nothing for the next 12 or so years of life, however long it takes from birth to the onset of puberty. They don't all start doing the next thing right as puberty sets in. Rather, each ovarian cycle leads to a small number of these cells progressing on here. Only one of them gets to the point where it divides to make a secondary oocyte. And then that secondary oocyte does not complete the second round of meiosis unless fertilization takes place. So for most of the egg cells that a woman produces throughout her life, they don't complete all of meiosis, only the ones that are fertilized by egg cells. If your last name is Duggar, which I know none of you are, but for people whose last name is Duggar, they do a pretty good return on ovary to fertilization ratios. But for most people, there's a lot of cells that never complete this just because they don't get to the point of being fertilized. After fertilization, the second division here again is asymmetrical. Half of the genetic material ends up in a polar body, the other half stays in the egg cell. All of the cytoplasm stays in the egg cell. And then that egg cell is available to progress through the embryonic development. I show a picture at the beginning of lab, which I did yesterday or will next week, of an egg cell covered with a bunch of sperm. You can see the difference in size between the two cells. It's much more than is suggested here. The asymmetrical divisions that I'm talking about here is really so that this egg cell is huge and it has a lot of cytoplasm to direct all of the divisions that are going to take place until the zygote, which is what we call the sort of precursor to the embryo. Before the zygote implants into the placental wall, the cytoplasm of the egg cell is what's responsible for directing all cellular activity. So there has to be a lot of it there. The sperm does not contribute anything more than its genetic information. The sperm cell actually has mitochondria, but except in very rare occasions, all the mitochondria that are present in a person came originally from the mother's egg cell. You can do genetic analysis on DNA that's found in mitochondria, and it's always going to follow back the maternal line. There should be absolutely no introduction of paternal mitochondrial DNA in the reproductive cycle. That's actually a fairly powerful tool in the laboratory. If you want to get any long-term look at what's happening genetically through humans, mitochondrial DNA analysis tells you a lot. There's a very famous study in a popularized book, not popularized book, but a general consumption book written to describe what's going on here, looking at mitochondrial DNA used to track the genetic variation within the entire human population. And it's provided the most definitive evidence of the paleohistoric rise of modern humans. The book is called The Search for Eve, of course, making an allusion to the biblical story. Not to say that they discovered Eve in the biblical sense. I shouldn't say it that way, have discovered Eve based on the biblical story, but rather they were able to trace mitochondrial DNA back far enough to find a common human ancestor for all living humans. And so since it is mitochondrial DNA and therefore is only through the maternal line, that ancestral human would have been the mother of all humans. And so sort of tying in with the biblical story, they called her Eve. It showed that modern humans came out of the sub-Saharan Africa region and then distributed through Asia and Europe and the rest of Africa. And there's very good evidence saying what happened there. If you're interested in it, again, the book is called The Search for Eve. It's really good. It's probably about 20 years old now. But it's a really interesting look at the power of genetic information and the tools that we have available to look at that sort of thing. If you're really interested, then you want to get in further to that. There's a lot of research going on now looking at what we consider modern humans and Neanderthals, looking at genetic markers and getting more evidence to fit in with the I can never say these words right, paleoanthropology of the human genome, that sort of thing. So if you're interested in that stuff, it exists. But the point I was starting to make there is that the egg cell, it has all of the cytoplasm that's there for the cell divisions that are going to take place from fertilization on till at least implantation. There are 4 gametes that are made through meiosis. So here we have the one egg cell. We end up with 3 polar bodies, which again, I said, it's possible that polar bodies will be discovered to be much more important in development later on, but at this point, there's no evidence of that I know of. These second polar bodies represented as a second division from the first polar body may or may not actually exist. I mean, it's not like they're a figment of somebody's imagination, but in some cases, the first polar body doesn't go through division to make these 2 second polar bodies. But just to complete the idea of the generation of 4 gametes from a single cell, they're all demonstrated here. And there are certainly occasions where all of the polar bodies are made there. But, now, if we look at what's going on in the ovary a little bit more closely, sort of building on top of what I was just showing there with the meiotic divisions, we start to look at what's considered the ovarian cycle, okay? And this is something that's going to happen on a repeating basis every, on average, month. We're going to be working with the idea that These cycles happen on a 28-day cycle. That varies from woman to woman, but that's the average we're going to deal with. So every 28 days, sort of what we're looking at here occurs for each woman. Now, before the cycle starts, in the ovarian cortex, there are cells sitting around doing nothing. Those are the cells that entered into meiosis before the woman was born, and they're just waiting for the signal after puberty telling them what to do. These are referred to as primordial follicles. So we have this rather large cell here. They're pointing out the nucleus, and then the surrounding clear space in the picture represents its cytoplasm. So this is the oocyte. This is the primary oocyte. It's surrounded by some supporting cells, which have not fully differentiated into what they're going to be. The ones that are right adjacent to the oocyte, they're labeled down here as granulosa cells. Granulosa refers to cells that have a grainy appearance. These do not have a grainy appearance at this point, but these are the cells that are going to be grainy in appearance later on. So primordial follicles are what's sitting there in the ovarian cortex until they're called upon. And so with the beginning of each ovarian cycle, one or a few primordial follicles will be stimulated to start progressing through these growth stages. The first thing that happens is the primordial follicle becomes the primary follicle. We still have the primary oocyte here. It hasn't completed its first division yet. The granulosa cells start to divide and become more grainy in appearance, making sort of a surrounding border enclosing the rest of the follicle. Sometime later, the primary follicle becomes the secondary follicle. And the sign for when this occurs is when the granulosa cells start to become quite thick, multiple layers of cells, and a rupture occurs within the granulosa cell layer. That rupture is going to make for some clear space surrounding the oocyte, as we see here. It's kind of odd the way that they've depicted this in this picture. It looks as if the oocyte is floating around in the middle by itself. It's actually attached to the edge of the follicle at one point. If you take a section through a cell, there's a slim chance that you'll actually section through a single feature. So it's a spherical follicle. And if you just cut at random through it, the majority of times you're going to see a picture like this with the oocyte looking like it's floating in the middle. But in fact, if this picture's of an actual micrograph, somewhere out of the plane of section, some of the granulosa cells extend and make kind of a connection to the oocyte. And we can actually see that in the next picture. At some point, the space around the oocyte that we see here grows to be rather significant in size, and we get to the tertiary or mature follicle. The oocyte now is depicted as a very small cell here, not because it's gotten smaller, but they've just changed the scale of the picture. So this cell here is just represented as a little cell right there. In fact, that cell's probably grown in size. So we're really pulling out to look at the whole follicle as a bigger structure around that. The empty space that we see in the secondary follicle is the empty space that we see here, which is labeled as the antrum. Depicted in that empty space, there seems to be stuff there, and there is. It's sort of cellular debris and some fluid with things suspended in it. That's present in the secondary follicle. It just, they're making more of a point of it here. And it's a bigger component of what's in the follicle, and you can see it a little bit more clearly. But we can see the oocyte is attached to the edge of the follicle through some of the granulosa cells. So this picture here is depicting a plane of section where we can actually see that feature. That feature is present here, it's just not depicted in the picture. Okay, again, because it's just a matter of chance if you slice through the structure you want to actually see, so they don't depict it there. Now, in the tertiary and secondary follicle pictures, they're labeling a couple of cells outside of the follicle here or out here called theca cells or thecal cells. Some sources will have an L at the end of that, making it actually an adjective form of the word. But those are some of the cells that are outside here. They're just not depicted or labeled in the primary follicle, but they are some of these cells in the surrounding cortical area that are specializing to do something. And what they're specializing to do has something to do with the hormones that we'll be talking about later on. But those are the thecal cells. So I want to point those out because we'll come back to them later on. Now, the tertiary follicle is also known as the mature follicle, and I think that's a slightly better term for it. It is the third stage of the follicle, primary, secondary, tertiary, but also it's the stage of the follicle that's going to rupture at ovulation. So when it's gotten to this point here, it's about to rupture at ovulation, which is the next stage that happens here. Now, depictions of ovulation, like this drawing here or other micrographs, are always kind of weird looking because visualizing ovulation actually happening is impossible in the kind of preparation we're going to get a micrograph of that these other pictures are based on. Because it's a dynamic process, the preparation of tissue for microscopy would basically erase any evidence of ovulation that might have taken place. So these kinds of pictures actually have to be taken in an actual living ovary. And this picture and actually the picture with the introductory part of the chapter here. So this is a picture of ovulation taking place, which you can't really make much of what's going on there. But this is a picture in living tissue of this happening on the edge of an ovary. And only actually, I think last year or the year before, did we have really good pictures of this kind of stuff happening in human ovaries. So this might actually be a picture from a different species. It doesn't say in the text down here what species this is from, but that's what ovulation looks like because of what's necessary and how to take a picture of it. But what happens at ovulation is the oocyte is released. It's surrounded by some of the granulosa cells. So some of the granulosa cells that are attached to the ovary, to the oocyte here in the mature follicle, they're released at ovulation. Okay, so we see a little bit of a halo or corona associated with that, which are granulosa cells. And that's the cell being released from the ovary. The ruptured follicle we can see down below here. And those are the granulosa cells that are left over after the ovum has been released. The ruptured follicle persists in the ovary as what's called the corpus luteum. Now, corpus in Latin means body, so the body or structure. And then luteum is referring to the fact that it has a yellowish color, and that's where that term comes from. So the corpus luteum is really the remnants of the follicle after ovulation, and that persists through the rest of the ovarian cycle. Now, at the beginning, I said what's happening here is taking place over, on average, 28 days. The primordial follicle is what's present before the cycle starts, and then at the start of the cycle, we see the primary follicle develop, and then it gets more complex as the secondary, and more complex as the tertiary or mature follicle, which then ruptures at ovulation. Ovulation takes place at the midpoint in the cycle, so day 14. We see here 6 figures. Number 1 is actually prior to the start of the cycle. So really the cycle that we're talking about is represented in 5 figures, the 4th of which, number 5 here, is the halfway point of the cycle. So the second half of the cycle, 14 more days in this set of pictures is represented by the corpus luteum. It doesn't do anything really. There's not a whole lot of changing taking place in here, but it's it's what we see in the ovary for the rest of the cycle. What we're going to do from here is talking about how the hormones in the system relate to what's going on, regulate it, and what hormones come out of this, which is represented in the book with this picture here, which is rather complex. And I'm not going to try to get into that now. So we'll pick up with that next time. And we'll finish talking about the ovarian cycle, and then we'll finish the female reproductive system, concentrating on the uterus and the uterine cycle, and then tying it all together with the overall thing. So we'll do that on Thursday. Like I said, I'm pretty sure we'll finish up